Okay, so ready to get started. Today we're going to be talking about building a scalable vulnerability management program for effective risk management. I am Katie Perry, not that one. So if you showed up here hoping for a concert, then hope you're not too disappointed. Oh, okay. You can hear better? Okay. So I'm the manager of the Vulnerability Management Program at Discovery Communications, home of the Discovery Channel, TLC, Animal Planet, Velocity, among some other pretty cool networks. And prior to my current role, which I've been in for about 10 months now, I was at Visa at their vulnerability management team. So this talk is going to be based on my experience at both of those organizations. So to kind of segue into this topic, because probably most of the talks you're going to today have been about offensive security, and so this is going to be about defensive security. So now that you've identified all of these vulnerabilities that allow you to perform all these cool exploits that you've been hearing about today, where do you go from there? In a large environment, it wouldn't be unusual to have over 1 million active vulnerabilities. And you probably don't have an extra team who's dedicated totally to fixing them. So how do you prioritize? What do you do with this huge amount of data that you just got? So I'm hoping that by the end of the talk, if you're ever given that task, here's your vulnerabilities, now what do I do with them? You'll have some good ideas about how to form a strategy around that. Okay, so vulnerability management. When we're talking about vulnerabilities, it's some kind of flaw or error that can be exploited to violate the system security policy. So some examples would be the Apache struts vulnerability that was recently announced a week or two ago, I think. That's a remote code execution one. It's super nasty, so if you haven't checked your environment for that one yet, I would highly recommend doing that right away because it's being exploited in the wild and it's very easy to exploit. So you definitely want to check that one out if you haven't yet. Heartbleed is an example of an SSL memory leak vulnerability. Poodle is SSL and TLS block cipher mode padding. Ghost is a buffer overflow in a Linux module. There is a certain version of Windows where you can exploit SMB to cause a denial of service attack. Telnet being enabled, that's an example of a vulnerability too, because Telnet transmits in plain text. And a web application being vulnerable to a SQL injection attack. That's also an example. So we can see, you can find vulnerabilities on the application level, the operating system level, or even the firmware level. So when we're talking about vulnerabilities, we're talking about all of these things. A vulnerability instance. So that means one vulnerability on one asset, on one port, on one application. Now, I think why I need to define that will make sense a little bit later into the talk, but when we get into metrics and communicating the findings to the people who need to remediate them. So say, for example, you have these two different applications running on your host, and they both have Java embedded, and Java needs to be updated on both of those applications. You need to count that as two vulnerabilities. One, so that when the person goes to remediate it for you, they know to fix both. And also when you're reporting quantity to up to upper level management, you're counting that as two findings because they're two distinct findings that both need to be addressed separately. Actionable. When we say that, we're describing a vulnerability that has a known fix. So there are vulnerabilities out there that the vendor has decided not to come up with a fix for. Those wouldn't be actionable, and so they need to be handled differently than ones where we can apply a fix. Severity, that's the measure of risk resulting from a vulnerability instance. Typically, people use critical, high, medium, or low to describe the severity of a vulnerability, but you could also use a numeric value. The CVSS score is on a scale of 1 to 10 or 0 to 10. I'm not sure if it starts at 0 at 1, but it's a numeric value, so you could also use that. But typically, I think you're going to find people are using critical, high, medium, or low. Risk management, it's the act of determining what threats your organization faces, analyzing your vulnerabilities to assess the threat level, and determining how you will address the risk. So once you've found all these vulnerabilities, you can deal with them in three ways. You can mitigate the risk, so you would fix it. You could transfer it, so some ways you could do that. You could purchase cybersecurity insurance, or you could have a third party host the application, and they would be the ones responsible if it gets attacked. Or you could accept the risk, and you're just going to say, look, it costs more to fix the vulnerability than it does if someone were to exploit it. So the business decides, we're just going to accept that risk. And that's a business decision. That's probably not your decision as an information security professional. I think for us, the main thing is that we provide the business with all of the information so that they can make a good, solid, educated decision about what to do with the risk and how to handle it. Because at the end of the day, they have that business context that we don't have. So they need to be the ones that decide, okay, well, where do we go from there? But we give them all the, background knowledge from a security perspective. So the vulnerability management lifecycle starts with prioritizing your assets. So you need to know what do they support in your business? So for example, if you're working at a payments processing industry, like Visa, then the business is to process payments. So those systems that are doing the processing of the credit card transactions, those are your very most critical assets to the business. At Discovery, we are broadcasting TV shows. So the systems that are actually broadcasting the TV shows, those are the absolute most critical assets. And so you need to know that so that when you prioritize remediation, you're making sure that you're fixing those, those prime things that are most important to the business. And then detection. So you run your vulnerability scan, and you find the vulnerabilities. Then you report them to the stakeholders and to the parties who are going to be remediating the findings. Then your sysadmins will remediate them. And then they're going to want to come back and do another scan to make sure that the patch or whatever solution they implemented actually fixed the vulnerability. So in the verify stage, they're going to want to go back and rescan to make sure it worked. And, this is a continuous cycle because the environment's always changing and new vulnerabilities are always being found. So this is continuous. So the characteristics of a successful vulnerability management program, scope completeness. So you want to make sure you find as much as possible. You want to make sure you're covering your entire environment. So there's two parts to that. There's everything in your environment, which is the network space. And then you want to make sure you're checking for as many vulnerabilities as you can check for. So you want to make sure you're using a tool that has plenty of vulnerability signatures to cover everything. And then the other part to that is authenticated scanning versus unauthenticated scanning. So if you're running a vulnerability scan and you don't have authenticated access or you don't have an agent installed on it, then you have limited visibility into the asset and therefore you won't be able to detect all of the vulnerabilities. So in order to get complete scope, you would want to have credentialed access to the host, whether it be with credentials through authentication or with an agent installed locally on the host. Efficiently integrates with pre-existing business processes in real time. So I think there's two key words in that point. One is efficiently. When you go in and start a vulnerability management program, there's probably already some kind of patch management program in place, hopefully. And so you want to make sure that, you're going with whatever they're doing already in terms of how it relates to vulnerability management. And then the real-time point. When things come up like the struts vulnerability, someone like your CEO is going to hear about that and he's probably not going to be technical. He's just going to be like, oh, there's something really bad. I need to know what's the exposure in the environment. So that ask is going to roll downhill to you, and you're going to have to answer that question. So if you're running vulnerability scans on, say, a weekly basis, you can't say, let me get back to you next week, CEO. So you need to make sure that your solution is providing you with that data in real time so that you can answer questions like that and the process is efficient. So for vulnerability scanning, you can have either an agent solution, an agentless solution, or a combination of both. So the agent provides that real-time data that you need. The way it works is you install it on the host. It will check for all the vulnerabilities and then send that data back up to, if you're using a cloud solution, then it'll be in the cloud or wherever that data is being stored. It'll send that back. And then it will only report back when the system changes. So for deltas, the difference between that and an agentless solution, with an agentless solution, you would have a scanner. And anytime you want to look for vulnerabilities, you would have to run a scan and it would run through a check of every single vulnerability. So, the reason that we can't just use agents, because, like I said, the agents are really beneficial, is because realistically, you're not going to get the agent installed on every single asset in your environment. And also there's going to be platforms where the agent won't be compatible, like IoT types of devices, and things like that. So the agent's never going to be able to cover everything. So for the parts that it can't cover, you still want to have that scanner. You still want to be scanning your entire subnet space. And you also want to identify rogue assets. If someone plugs something into your network, and you're just relying on wherever the agent is installed, then you wouldn't know about it unless you were running a scan of the whole network space. Measurable progress. So you need a way to show that you're making improvements, that you're reducing risk to the environment. And it can get really complicated, as you'll see in later slides, when you have all this data to try to show that, because there's a lot of different things going on, and you're going to get asked questions that may seem really simple, like, oh, are we doing better? Are we remediating things faster? Those seem like simple, reasonable questions, but when it gets down to it, there are so many factors that affect what's going on, as I'll describe later. You just need to be able to make sure that you can communicate that correctly. And your program should be audit proof. So depending on what organization you're at, you may or may not have a lot of compliance policies that you're forced to abide by. So comparing my current organization to my last one, so going from the payments industry to the TV broadcasting media industry, there were far more audit requirements in the payment industry. Definitely had to talk to auditors, I would say at least once every other week. They were always coming to ask questions, about how we were doing things and the data we were collecting and everything like that. But I think that even if you are somewhere like where I am now in the media industry, where we don't have so many compliance regulations we need to abide by, it's still good to build your program in a way that you can justify, that you have your processes down, you're following them, and a lot of it's automated, so there's not a lot of room for human error. So that's just best practices way to design it, whether or not you have to answer to auditors. So the stakeholders in this process, you have executive leadership. Now, depending on the organization, again, like sometimes this goes all the way up to the board of directors. In other organizations, it stops at the CISO maybe. So depending on, where it is, there's some leadership though that's coming down and they want to know, the risk in the environment, the vulnerabilities in the environment. And this audience is not technical. You basically want to be able to communicate to them, okay, what does this mean for them to the business? You have your system owners. Those are the people who have to make the decision about how to address the risk. They own the system. They know what it's used for. They're responsible for signing off on the vulnerabilities, or, if there's going to be an exception for them, or making sure that they have resources dedicated to remediating them. Your information security team, they run the vulnerability scans and manage the data that comes out of that. Then you have your auditors and system administrators. So system administrators are the ones doing the actual remediation. So the components to this program, you have your vulnerability scanner, and then you want some kind of back-end database where you take that scan data, you keep it there, and then you also take your network inventory, your asset inventory in the CMDB, and then the ticketing data for the vulnerability tickets that you issue to get the remediation accomplished. You want to store all of that in your back-end database so that you can produce these detailed reports and give context to this information. Your front-end dashboard. There's two purposes for that. One is the metrics. So you want to provide some good charts on there. And then workflow. So ideally, what I'm about to show you is going to be like a one-stop shop for everybody that's involved in the entire vulnerability management process, with the end goal being efficiency. Oh, sure. You have a question? Yes, and so that's why we, so for scanning purposes, you want to scan all the subnets. Usually there's some kind of subnet inventory like Infoblocks or some other type of tool where you at least know your IP address space. And then that's what you base your scope of scanning off of. But then if you have some kind of asset inventory that gives you details like, okay, who's responsible for this asset? That's how you know how to assign the vulnerability ticket to. And also, how critical is this asset? Is it, in your top critical environment, and therefore any vulnerabilities on it should be prioritized. That is what you get out of CMDB. And ideally, you want to encourage them to update CMDB with this information because it only helps you. But from a scanning perspective, you could create your own asset inventory. But again, the thing that doesn't provide is the business context. So does that answer your question? Okay, thanks. Then the ticketing system. So again, that's the other piece. That's for your vulnerability tickets. So I would recommend when choosing the ticketing system to use for these, you probably want to use whatever your support groups are already using. A lot of times their performance and metrics are all based off of tickets that they work on and close. And so it's just like added incentive for them to actually, complete your requests if you utilize their ticketing system. So the architecture on a high level. So the reason I'm keeping this high level is because there are a number of ways you can implement this. You could build your own back-end database yourself and use some kind of front-end solution like Tableau, or and there's any number of solutions. Or there are some solutions where this is all bundled together, like RSA Archer's product. So the reason I'm trying to keep this high level is that you need to determine what's best for your organization. There's a lot of considerations that need to go into deciding how to architect this, and there's pros and cons to those solutions. So I'm trying to paint the picture on a high level where you want to go, and then for your individual organization, you figure out exactly what's the best way to architect this. So we have the vulnerability scanner, the network inventory, the CMDB, and the ticketing system all talking back and forth to the database. So these arrows go both ways because you want to grab all that information from those sources, but then also you want your users, when I was talking about workflow, to go into the front-end dashboard and for example, update something in the ticket. They fixed the vulnerability, they want to close it, or they want to re-kick off a scan to make sure that their remediation worked. So they, click a button and that tells the vulnerability scanner, kick off another scan and let me know if it worked. Okay, so this is an example of what your backend database might look like. I'm not going to get into every piece of data that's here because that would take too long. But this is an example just to kind of show you what we're storing in here. Up at the top left corner, Infoblocks, that would be your subnet inventory. As you can see, that's one challenge in itself, because if you're storing a list of subnets, you want to be able to compare that to each individual IP address that comes back from your vulnerability scanner. So discovered host table underneath that's just a list of hosts that your vulnerability scanner discovered. So mathematically, it's doable to say, okay, you have this given IP address, what subnet does it belong to, or does it belong to a subnet in your Infoblocks table. But from a database perspective, you have to do some engineering there to make that join. And as you can see, I have some various history tables. The purpose of that is that the leadership definitely loves to hear about trending. You definitely want to include trending reports in your front-end dashboard for them because they love to see things over time. It's definitely a big challenge, though, because things change so much, and like I said, they're going to ask questions. Well, why did the number of vulnerabilities go up this one month? Okay, like I'm managing 80,000 assets, and dozens and dozens of vulnerabilities come out every week. You know, you have to figure out how to answer those questions. But anyway, so your front-end dashboard, ideally you would want to have a different page for each of your stakeholder groups. So think of your stakeholders like having a role for each of one of those. So when the CTO logs in, he should not be seeing the same thing as a sysadmin. You know, the CTO just wants to see charts and big picture ideas, whereas somebody who's doing remediation is going to want to see, you know, these itemized, listed out details so they can click in and they can say, okay, like I want to fix this now, or, you know, I need to deploy this to however many hosts. And this is all the information. This is where I can find them, their IP address, host name, etc. So the processes involved in vulnerability scanning, rating the vulnerabilities. So I'm going to go into detail of all of these processes. So I guess I'll just list them out now, and then we'll get into detail after this. Then you have remediation. So you can either So you have your patch management process and your configuration management process, asset decommissioning, false positives, exceptions. And there's two types of exceptions. There's the exception where they're going to accept the risk for vulnerability and decide not to fix it. Or sometimes they don't want to scan certain assets on the network because typically like IoT devices and non-standard platforms don't play well with vulnerability scanners. They weren't meant to handle normal internet traffic. And, you know, vulnerability scans are supposed to be passive. They're not intended to be like pen test type of activities or offensive type activities that are supposed to cause any harm or anything to the system. So if that does happen, it's really because it's some kind of non-standard platform that was not made to handle regular traffic that you would see all over the internet. Handling findings that have no fix available is another process. Then you have audit, and then continuous scope maintenance. So when we're talking about vulnerability severity rating, there's multiple things you want to take into account here. So asset criticality, again, you can rank them on your critical environment. And then ideally, if you want to get really advanced, you could have confidentiality, integrity, and availability ratings for each of the hosts. So how important are each of those things on each host? And you weigh that into your criticality score. Then you can use CVSS score as part of that rating. And then any mitigating controls you have in your environment. So say, for example, you have some kind of web app vulnerability, but then you also have a WAF implemented that's going to block any attacks on that vulnerability that may cause you to, you know, deprioritize or decrease the severity of that particular vulnerability. At the end of the day, you still want to fix your vulnerabilities, even if you have that added layer of protection. An attacker is eventually going to get around something like a WAF, but at least that will slow them down. So it helps, but yeah. So for remediation, this is going to be your sysadmin, mostly, who's logging here. You have identified for him all the hosts that need remediation. So I've just chosen, for the sake of having an example, I've chosen this one Microsoft patch. Okay, so your sysadmin's like, okay, patch Tuesday happened. It's time for me to go update the Windows host with this patch. So you give him the list of, well, okay, he goes into your front-end dashboard and looks up, okay, what are all the hosts that need this patch? So it'll have some kind of search box like that. And then what could happen, he might determine that it's a false positive. He might go to apply that update to one of the Windows hosts, and it'll say, this update is not applicable to this system. And so then he would follow the false positive process, and we'll get into what that entails in a minute. But say it's not false positive, then the next step is deploy a fix to the development environment, right? Because you want to test the fix in development before deploying to production. So ideally, if you have your front end dashboard talking to whatever tool they use for their patch management process, like they might have something like BigFix to deploy patches. If that sysadmin can go into your front end dashboard, he can see all the hosts that he needs to update, and then he can just highlight them, and then that sends off a message to BigFix or whatever the tool is to go deploy the patch. That's a really efficient process. So at the end of the day, that's the kind of efficiency we're talking about. And then after that, he's going to want to make sure that the fix actually remediated the problem. So he would just go right back into the dashboard, kick off a scan on those hosts, or if they have the agent installed, then there's not even a need to kick off another scan, and search on them, make sure that they're now showing as fixed. If there's any problem that goes on with that testing, say the update broke some application that was running on the host, then you would want to go to the exceptions process, file for an exception for that vulnerability. Okay, so after that, if everything was good, then you want to deploy it to QA in production environments. And then after that, you want to rescan again or refresh if you're using agents, and close all the tickets associated with the finding. The asset decommissioning process. So the challenge with what happens when assets are decommissioned, a vulnerability only gets marked as fixed when the scanner can confirm that it has been fixed. So if you take something off the network, then it's not coming back, so technically the vulnerability is gone. You want to consider it fixed, but you have no way of knowing that, the host just didn't happen to be powered down when you were scanning it or what. You don't know if it's coming back on the network. So the way we've handled this is if we haven't seen the host in the past 30 days, so in other words, if the scanner hasn't seen it, if the agent hasn't checked in 30 days, then we consider that, okay, that's decommissioned, that's off the wire. We're going to mark, all those findings as fixed. Now, the people who are doing the remediation, they don't want to wait 30 days to get the credit for fixing it. So, the solution we gave them is, okay, then go into CMDB, mark the asset as decommissioned, and then for those assets, we'll just give it a 7-day window to make sure it's been off the wire, and for those ones after 7 days, then we'll consider it fixed. False positives. So sometimes there are going to be cases where, you have false positives. There are some really great scanning tools out there in technology that really minimize false positives. So hopefully you won't have to deal with this much, but, nothing's perfect. So at some point you probably will. So what begins this process is the hosts that you've been given that need remediation. You've determined that the fix has already been applied or it's not applicable to the technology. So what you want to do is you want to take some screenshots. Well, if you're the system administrator, then you want to take some screenshots showing the evidence like, hey, this is not applicable, or look, I already fixed this, but it's still showing up as active. And you send that to the vulnerability management team. And then we'll review it. And then if we think, that's correct, then we're going to send it to the vendor and have them fix it. So, but you also want to track that in your metrics, because again, people are going to get mad if you're saying you have these vulnerabilities, but it's actually a false positive. So you go back to your front-end database and mark those as false positive in this case. Then the vendor hopefully eventually fixes the vulnerability signature for you, so that going forward it correctly identifies the vulnerability and there's no more false positive. Then the VM team verifies that the vendor fixed it correctly and then goes back into the database and takes away the false positive designation. So here's some detailed examples of how a false positive can happen. So these are actually real examples that my team came across last year. And this was actually both of these were on the same host, so that's why you'll see that the timestamps are the same. So the first one is an unchecked buffer in DirectX that could enable system compromise. So this came back from a vulnerability scanner. What you always want to check first in these cases when your sysadmin says this is a false positive, the first thing you always want to check is the date, because a lot of times it's just as simple as they're looking at data that's old. So again, if you have the agent installed, then that's a non-issue. Then we see the operating system is Windows 10 and the results. So what the results tell you is it gives you some insight into how the signature is working. So in this case, the signature is checking this quartz.dll file version, and that's how it's determining whether or not the system is vulnerable and needs this Windows update. So some sysadmin, reported this to us as a false positive. So we went to the knowledge base article on Microsoft's site about this patch, and we can see that the affected software list, Windows 10 isn't on that list. It's not applicable. So they were correct. So we had to report that to the vendor, and they fixed it for us. This other example is a .NET framework collection of vulnerabilities that are addressed by this update MS15 118. So we can see in the results that it's checking for the version of this system.deployment.dll file. But again, we see that it's only applicable to Windows 2008 or Vista, and we're running a Windows 10 host, so it's not applicable. So one thing to note though about the operating system version that comes back, if you're running a scan that's not authenticated or is not with the agent, then it's a best guess effort. So it's like if you run an Nmap scan and you can fingerprint the operating system, basically with an unauthenticated scan, that's what it's doing. So it's not always 100% accurate. But if you do have authenticated or agent access, then it should be accurate all the time. Exceptions process. Okay. So the patch or configuration change was not, jiving with the software or applications that you're running on the host or some reason like that. So you need to file an exception request. A sysadmin can go into your front-end dashboard and put in all the details about it, how long they want it to be for, and everything. So you're going to store all this information in the back-end database once they put it in the front end. So then the exception request goes for approval or being denied by information security team and all the stakeholders. And then finally, the vulnerability findings in your database are designated as under exception. So that's something you want to communicate when you're creating your dashboards and reports for management. So then you have findings that have no fix available. You should report these to the architecture team because then they can look into mitigating controls. So just because there's no fix to it doesn't mean that there's not something else you can do to reduce the likelihood that someone's going to exploit the vulnerability. So that's the purpose of providing this report to the architecture team on a regular basis. Yeah, so that's pretty much an overview of that process. So audit, the things that they're going to ask about the most are scope, again, making sure you have completeness. What are your SLAs? So you need to have a timeline for how quickly the sysadmins need to remediate your findings. Usually it's something like, okay, critical findings have to be remediated in a week, and then high, medium, low are 30, 60, 90 days, something like that. So audit's going to want to know, are the sysadmins meeting those SLAs? And so you're going to need to be able to run reports showing that. So in general, just a tip for handling auditors, you should ask them for the test cases ahead of time, and then you go run the reports for them. You can get down a long rabbit hole if you show your your tools to the auditors, because they're just going to ask a lot of questions. They're going to say, well, what about this? What about that? And you could be with them forever. So that's just a little tip for handling auditors. Continuous scope maintenance. So again, the environment is always changing. New servers are coming on. Servers are being decommissioned. New vulnerabilities are coming up. New applications. So that's something you always have to keep current. So you want to make sure you're always having authenticated access to the host, whether it's through credentials or agents. So you want to have a dashboard for yourself in your interface that's going to show you these authentication reports. Metrics. So some of the things you want to report on the dashboard. How much risk exists now? So this is a question like CTO and leadership above that level are going to want to know. So one of the ways you can show this is, what are all my vulnerability instances by severity, region, and support group? And then what are the top 10 support groups and technologies with actionable vulnerability instances? Information like that can actually also influence what kind of technology the organization decides to deploy. Because say, for example, Java is one of those technologies that constantly has vulnerabilities, constantly needs updating. So if it's costing, their admins X number of hours to always keep patching Java, then the business might say, okay, maybe we need to look at a different technology to meet this solution. So how well are we managing risk? So I would say the best way to show that is the delta between the fixed vulnerabilities and the new vulnerabilities, because it's not a constant pace, like how quickly new vulnerabilities are going to be identified. So you can't simply say, okay, we fixed this many. We need to know like how quickly we're closing that gap between the new ones and how quickly we're fixing them. So you can show a report of fixed vulnerability instances by date, severity, and SLA status. They fixed it, but did they fix it on time? Then new vulnerability instances by severity. So upcoming workload, this is something that your operations team will want to know. It's good information for them if you're like, okay, so Windows findings in the next 4 weeks, there's going to be, 20,000 of them due. So then the leaders of that team are going to know, oh, my Windows team is going to be busy coming up. They're going to have a lot on their hands. Trending data. Again, leadership loves trending. They want to know how everybody's doing, how, the story. You have to tell the story from beginning to end. Data integrity. So again, going back to the authenticated scanning versus unauthenticated scanning, if you don't have authentication, if something doesn't work, then you're going to be limited in the signatures that you can check for. So we started out with our Cyber Information Center connecting into our vulnerability scanner, network inventory, CMDB, and the ticketing system. Taking this all a step further, we can connect into all these other areas that involve security to show a real complete risk description to our CTO or whatever other stakeholders are interested. So we can hook them into the patch deployment tool. Again, that makes it quicker for a sysadmin to go and see the vulnerability, and remediate it, one-stop shop. The pen test findings. So sometimes your pen tester will come in and they'll find some of the same findings that your vulnerability scanner found. Sysadmins get cranky when they see multiple tickets for the same thing. They're like, we saw it from vulnerability scanner and now I'm seeing it from your pen tester. You don't need to tell me twice. Okay, so if we get all that integrated into the same backend database, then, we can just report it to them once. Your baseline configuration scanner, it's good to have that data into so that you're tracking, what configuration changes need to be made, what baselines were created correctly according to your policies, etc. Audit findings, your threat intelligence platform. That's really cool if you can integrate prioritizing vulnerability remediation on threat intelligence. So say this particular hacker group comes out and they're, targeting this one particular vulnerability, then you probably want to increase the severity of that vulnerability. So if you have a threat intelligence platform that you can hook into and get that data integrated into your severity rating, then that's definitely a value add. And then the other area is your security architecture, because what that can tell you is mitigating controls. Again, if you have mitigating controls in place, that could be a reason to decrease the severity of a finding. So some of the challenges you may face in vulnerability management, these are just some various things that I've come across working in this area. So for example, identifying the local path to SSL certificates. Your scanner is going to go out there and it can see the SSL certificate information from the outside. So if it's an expired certificate or if it's invalid or if it's self-signed, all those things are vulnerabilities. But if it's detecting that from the outside, it's not going to be able to tell you where that certificate lives locally on the host, and your sysadmin might not know for a particular host. And so they're like, where do I find this certificate? I know it's on this host, but I can't find it. And your vulnerability scanner doesn't tell you that either. So that's just one challenge I've seen. Scan results being delivered through a load balancer. So if you're using a scanner to scan, you're sending that traffic through the load balancer, and then when the results come back, they're coming back through the load balancer. So you don't know what host on the behind the load balancer it's actually talking about. But again, having the agent installed would avoid that problem. Determining when new firewall rules are needed for allowing scanner access to subnets. So if you can't see it, you don't know it exists. Assets that react adversely to scans, I mentioned that earlier, like IoT type devices, industrial control systems like your HVAC, your power supply, all these types of things that weren't really created with the thought of normal traffic in mind. Reluctance to install security tools on assets due to high CPU usage. Security tools get a bad rap about being CPU hogs. They're like, you're running all these things on my host, you're making it slow. So you may get some pushback from the technology team if you ask them to install one more security agent on their hosts. Managing and securing service accounts used for scanning. So if you're using credentials instead of the agent, then hosts are going to come online, and they may not have privilege, or those credentials may not have privileges on those hosts, or they may expire, or it's also in a privileged account that has access to a lot of different hosts in your environment. So you have to make sure you secure those credentials too. In-house development versus using a COTS solution for your whole cyber information center. So again, it depends on your organization. I personally prefer developing it myself. I used to be a DBA, so it's not too hard for me to go create a database and, like I showed you in the database diagram before, and make the API calls to all these different sources and get it stood up myself. I like doing that because then I can design it based on how I know I need it to work. I don't have to be confined to the requirements of a COTS solution. But you're not always going to have a resource who can build that for you themselves. So sometimes you have to go with a COTS solution, or maybe your company, already has licenses for that solution. There's all these considerations that go into how you want to build this. So takeaways. Build your technology based on the business rules and processes, not the other way around. Don't get confined to the limitations of the technology that you use for the program. Define and document your business rules, including roles and responsibilities, caveats, limitations, dependencies, especially this whole CMDB aspect. If that's a manual source of data, then you can't really use that as the source you trust for the complete inventory, because it's just manual. And as we said before, it's rare to find an organization who has a good CMDB that's kept accurate. And devil's bargain. So I think what you're going to find, especially when you're getting a vulnerability management program started, like I said in the beginning, you could be handed over 1 million vulnerabilities, and the operations team is going to be like, I don't have the resources to fix all these. And so what I've seen happen before is the CISO will make bargains with them, like, okay, well, we'll extend your SLA on, these findings for this amount of time. And so then when you're responsible for creating metrics and telling the story, you have to remember that all those things happen. And so it can be really complicated to keep up with all of those things. So you have to document it well so that you're able to explain when somebody asks you questions like that. You can explain. Develop a vocabulary and use it. That's why we talked about some terms in the beginning, just so that everyone can understand what you're talking about. Remember your audience. Again, like I said, the dashboard the CTO sees should not be the dashboard that your sysadmin sees. And the more efficient your process is for remediators, the more they're going to remediate. So, basically make it efficient, automate as much as you can. And at the end of the day, you want to reduce as much risk as possible. So if you can make it an efficient process for the remediators, then you're probably going to be most successful. Does anyone have any questions? Yes. A CM, like content management, or like CMDB, or configuration management. Oh, so like a policy compliance scanner.
you want to use back end, the front end look at database of all assets?
Yeah, okay. So I've used Qualys as the vulnerability scanner at both organizations. I don't like to promote or demote any particular tool because there's no one size fits all for your organization, but I'm definitely a big fan of Qualys as your vulnerability scanner. It does also have an agent solution. Again, I liked to design the database myself. At Visa, I did not design our backend database myself. We used RSA Archer, and we just ran into a lot of situations where we were limited by the types of reports we could run. We would be taking snapshots of trending data, and then a leader would decide, oh wait, but what about like this data by severity? It's like we didn't take the snapshots by severity, so now we can't go back in time and answer that question for you. So if I have that, control to design the database myself so that I preserve that data and I can always answer those questions, that's why I personally prefer to develop it myself over a COTS product. There's also another solution called Kenna. And it's supposed to do a lot of these things, and the whole threat intelligence piece, it's supposed to also take that into consideration. It's supposed to also tie findings together. If like your pen tester found them and then your scanner found them, it's supposed to be able to know, okay, this is the same finding. So I would encourage you to, explore all the different options and, choose the one that's best for your organization. Sure, yes. With Qualys, it's less than 1/100%. That's what they advertise, and with my experience over the past 3 years, that's definitely been the case. I would say I reported 5 or 6 false positives to them, and I'm in environments where we have, 80,000 some assets. In a large environment like that, only 5, that's a really small number. So yeah, again, if you can get a good tool, then false positives should be a rare issue. Any other questions? Yes. I think it's wrapping your head around all the data. As you can see, this is kind of like a data project. It's beyond just the security. You have to explain this all to. You have to convert this to a language that your executive leadership can understand. Like, is your program successful or is it not? Are we doing better or are we not? And when you have all these caveats and all these things that can influence how many findings there are and how many are getting fixed, and it's really hard to wrap your head around all that data. You really have to keep a lot of different data points and find a way to query it all, make it all join together, and tell the right story.
So the answer is in dollars and cents. Plus this, you have to leave this equation dollar on vulnerability.
Yeah, so I haven't done that yet, but that would definitely be a good use case for this data. In the example I was talking about before, where if a technology is identified like Java, and you could say, okay, you could look at the tickets for these Java findings and show, okay, this is how many hours of labor were devoted to fixing Java updates. Then you could say, okay, well, this application is added cost due to ongoing remediation. So you could definitely make points like that. I haven't done it yet, but that's a good point because there are a lot of other use cases for this data. I mean, I think people don't realize the data that we collect in security can be used for so many other things that we can provide to the business that they want to know about. So that in itself is an extra value, I think. Yes?
I'm not sure you've used any cloud-based
Yeah, so like I said, Qualys it has a very low false positive rate. And I think one of the reasons it does is because it categorizes its findings on confirmed findings and potential findings. So confirmed ones, I mean, I've never even been in an organization that even looks at the potential findings. But the way it's defined is confirmed means every check within the signature came back as in, you know, that's definitely a vulnerability. If you get a potential finding, it means some of the checks in the signature came back and then other ones couldn't be determined. Maybe they didn't have access to the host or whatnot. But if you just look at the confirmed finding, it's a very small false positive rate. And Qualys is a cloud solution. Okay. So I think we're about out of time. So thanks for coming to this talk. I appreciate it.